Welcome to the Ultimate Statistics GCSE revision guide. Now we're going to go through all the topics that could possibly come up on the GCSE and just take you through some of the examples and things you need to know. So I've currently got up on the screen what is on the formula page. So you're given a definition for skew. Now some questions will literally give you a mean, median and standard deviation and just ask you to work it out. You're given two formula for standard deviation. Now, it's quite common to see questions where you're given one or both of these things and asked to work out the standard deviation. We're also given a definition for Spearman's rank. So here we need to know what Rn is and we need to work out our differences between our ranks. And finally, we're given quite a general formula for different rates of change. So this could be birth, this could be death, this could be anything that has a rate of change. So it's number of births per 1,000 people in the population. So that's what this one means. So we're going to go through a few of the topics in this video. So we've got what's called an arithmetic mean. So this is the mean that you're used to in the normal GCSE. So that's where we take our total and divide by how many there is. So again, n here just stands for how many there is. This sum of x just means you're adding up all your different values, which gives you a total. And this x bar is just another way of saying mean. So you could be asked to do a question like this, where we're asked to work out sum of x. So this means we are adding up all our values above and getting a value. So if we add all those values up above, we're going to get 1357. Now for x, it's going to be the sum of x's dividing by how many there is. So we're going to get that 1357 divided by how many bits of data there are. So your n is 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, both papers are calculator. So we can put this value straight into the calculator. And we're going to get 150.7 reoccurring. Another type of mean is what's called a geometric mean, where instead of adding up our values like we did in the arithmetic, we are multiplying them and then we are doing the root. So this root, we do the nth root. So if there is 10 bits of data, we're taking the 10th root. So if we look for an example here, our geometric mean, there's 9 bits of data, so it's the same data set as before. So we're going to do the 9th root, and we're going to multiply all our values together. Now, if we multiply all those values together, then take the 9th root, we get a total of 150, or we get a mean, I should say, of 150.6287 ... Another mean that we might be asked to do in the Stats GCSE is what's called a weighted mean. So this might come up when different things have different weight. So, for example, you might be comparing class results for a certain test. Now, one class might only have 15 students, and another class might have 30 students. So you might look for a weighted mean. Another example is when you have different papers in a test that count for different amounts. So here, the first two papers only count for 10%, and the last two papers count for 40%. So if we wanted our weighted mean, we have to take into account those different percentages. So what we're going to do is we're going to just rewrite these as decimals to be able to put these into our calculator. So we're going to have 0.1 and 0.4. And then to find out our weighted mean, we're going to times that by the respected value. So the first paper only counts for 10%, so it'll be 0.1 times what they scored in it, so 82. Paper 2, 0.1 times 79. Paper 3, 0.4 times 68. And paper 4, so it'll be 0.4 times 71. Again, we can just put this into our calculator. We'll end up with a value of 71.7. So that would be their average between the papers where their weighting is not the same. Another thing to do with averages is to be able to work out a mean or mode or median from a frequency table. So this question is looking for the mean. Now what we do with this one is we're going to multiply the number of cups by our frequency. So if we multiply that across, we're going to get 2, 9, 20, 40, and 30. Now if we add those up, that will give us our total. So remember, we're talking about mean equals total divided by n. Sometimes you might see this written as your frequency multiplied by your x and summing those up. So you've got your x, you've got your frequency divided by n. So this would technically be sum of f of x, this value down here. So 2 plus 9 plus 20 plus 40 plus 30 is going to give us 101. And our n is how many they add up to equal. So that's our total frequency. So 1 plus 4 plus 5 plus 8 plus 5, which is 22. So my mean is going to be 101 divided by 22, which comes out to be roughly 4.5909 ... If we have grouped values, so here, do you see it goes between 0 and 10? We have to work out the the middle value of that point. The middle value of this point, the midpoint, is 5, 15, 25, 35, and 45. And then we can do what we just did before. So this is would multiply across, add up, and do that division. Now we've got to be careful because this is just an estimate. The reason it's just an estimate is because these three values here could be anywhere between 0 and 10. We don't know where they are. We're just making a sensible guess that they're roughly 5. The other thing you might be asked to work out is what's called an interpolated median. So it wants you to find a best guess for the median rather than just saying the median falls within a particular class or a particular row. So when we do that, we are going to start by taking our total amount. So if we add them up here, which is 40, and we want the one that is halfway through. So we're going to do 40 divided by 2. We want to find the 20th value. So we're going to do our cumulative frequency for this table. So we're going to have 3. 3 plus 8 is 11. So the first 11 values come before the end of this group. 11 plus 7 is 18. And 18 plus 10 is going to be 28. Now we want to find the 20th value. Now this row here only goes up to 18. This then goes all the way up to 28. So it's somewhere between 3 and 4. So our interpolated median, what we're going to do is this row starts at 3. The difference between the starting and end point, so if we'll take away 3, which is going to give me 1. And then we want to see how far into this we go. Well, we started at 18. We want to get to the 20th value. So we've gone 2 into that. We've gone 2 into it out of 10. Now again, this is one we can feed straight into our calculator. So if we do that, we're going to get 3 plus 1 lot of 2 tenths, which is going to give me 3.2. That is my interpolated median. Don't get put off by this word. It's just asking you to do the process above.